Okay, today's lesson is about density. You can see the word here, density. Have you ever thought about why ice floats in your drink? Right? Ice is definitely at the top, not sitting on the bottom of the glass when you have a liquid in here. Hey, if ice didn't float, the Titanic would have made it. So why is ice floating? Well, it has to do with this property of density. The ice, the solid ice here, is actually less dense than the liquid water. You see the same thing happening with oil and vinegar. Top layer is oil here, and the bottom layer is vinegar. And even though it looks like there's a much larger amount of oil here, it still doesn't sit on the bottom. So it can't just be due to the volume. Here you might have assumed because the ice is smaller that that's why it's floating. But it's actually not the size of it. Okay, it's actually the density. So we're looking to understand this concept of density a bit better. Oil's the top layer, right? It's less dense than the bottom layer, the vinegar. What's actually happening at the particle level? Well, we can have two layers here. I'll just make that oil layer a little larger. And here I'm dropping in some particles of the oil, okay, and trying to kind of uniformly spread those around. So there's our oil layer. And then for the vinegar layer, I'm actually going to pack the particles more closely together. So I'm looking to illustrate now that the vinegar is more dense than the oil. So really, if I use a little green box here, I'm going to try to draw like the same size box, if you will, somewhere in each layer. Count the number of dots that you see in this green box. So 1, 2, 3, 4, 5, 6, I guess, maybe 6. And I'm going to come up to the oil layer, and I'm going to try to draw the same size box. So if I look at like something like this, maybe, right? It's about the same size box. So I'm trying to draw the same volume here and then count the number of dots. You can see that I only have 3 dots, 3 particles of oil in this volume, this green box, this green volume. And here I have 6 or 7 dots of the vinegar in this spot. And so here's where we can see the density, because density is actually the mass, as you can see here, per unit of volume of a substance. If the particles are where the mass of the substance comes from, then you can see that there's more mass of vinegar in this green box, in this volume, than there is of the oil. So the fact that we get 3 dots of oil in this volume, this green box, right, means that oil is less dense than vinegar, because vinegar gets 7 dots, 7 particles that have a mass, right, in this volume. So density really refers to the mass, right, the number of grams or kilograms that we have in a particular volume of a substance. So you're always going to find units with a ratio here, or a rate. Kind of like on the highway, you might see the speed limit, 100 kilometers per hour. Here we have a density in units of grams per milliliter. If the liquid, the substance you're working with is a liquid, it'll likely be measured the volume in milliliters. If it's a solid that you can measure, length times width times height, for example, you'll get centimeters cubed. Sometimes you'll see your density in units of kilograms per meter cubed. We can use the symbol D to represent density in a formula. So 2 terms have been mentioned in this definition, mass and volume. So what is mass? Well, we can, at its very basic, think of it simply as the amount of matter. We represent it with a lowercase m, and it's measured in grams or kilograms. The concept of mass is most commonly used like in everyday language as like, how much something weighs. But typically in science, or more correctly in science, the concept of weight, it's actually when the force of gravity acts on a particular mass. So the way you might think of like how much does that object weigh, that weighing idea is really mass. So, you step on the scale and it tells you weigh so many pounds. I mean, that's really your mass, not your weight, although I understand that we commonly use that term weight. Volume, right, is the amount of space that a sample of matter takes up, that it occupies. So you could have a volume of a a textbook, right? Occupying like length times width times height, that rectangular prism, or you could have a volume of water that's in a beaker, or your water bottle. So we have volume can be measured in milliliters, centimeters cubed, or meters cubed. So you'll notice here lowercase m for the mass and a capital V for the volume. So please make an effort to use these lowercase and uppercase letters. Density we see with a capital D. So I'm going to look now to develop the formula that relates density, mass, and volume. And I'm going to develop this formula by using the units. So just a refresher here that the units we can see in the table of the density are grams per milliliter. You can think of that as a fraction with grams in the numerator and milliliters in the denominator. So which quantity is measured in grams? So I'm looking for the numerator of my formula here. So when I have a look back over, I see mass, right, is measured in grams. Grams or kilograms, but this unit here had grams. So mass is the numerator. Milliliters is in the denominator here in the bottom of this fraction, so I look over and realize that volume is measured in milliliters. And so the relationship in a formula then is that capital D equals lowercase m over V. So D equals m over V is a formula that we can use to solve density problems. So if you're given the mass and the volume, you'll be able to substitute into this formula to solve for density. What if a different question gives you the density and asks you to find, let's say, the mass? So you're given D and V and you have to find m. Sometimes that happens. So we need to use a bit of our algebra skills to isolate the variable. So if we're looking, I'll just rewrite this over here. If we're looking to isolate the variable of mass here, this m, then I essentially want to get it by itself. So what's happening to mass here right now? Well, it's being divided by volume. So I can essentially undo that operation by doing the opposite. Right now it's being divided by volume, so I'm going to multiply by volume. And I do the same thing to both sides so that I don't affect the equality of this statement. Now that I see I have volume on the top on the right side and the bottom, it can be canceled. Volume divided by volume would just be 1. And so I have my mass left on the right side, and then I have V times D. Now I'm going to just write that as D times V, but really it's acceptable to write it the other way. Usually when we write a mathematical formula, we read it from left to right. So all I'm going to do is take the m that I have on the left side and write it first, and then take the D and V that I have on the left side and write them second. So we had one formula here that had density by itself. Here's a second formula now that has mass by itself. So I would use this formula if I've been given the mass and the volume. I would use this formula if I'm trying to find mass and I've been given the density and the volume. Now, what about if we're asked to find volume? So now I want to get V by itself. So remember, the idea is to notice the operation, the mathematical operation that's happening around this V. And right now it's D times V. When you see two variables beside each other, it means multiplication. So I'm going to do the opposite of that multiplication. I'm going to divide by D, but I need to do it to both sides so that I maintain the equality of the statement. Now, just like the V over V canceled, the D over D cancels. And that leaves me with V equals M over D. I'm going to turn around and write that as if I'm reading from left to right. V equals M over D, and this is the third version of the formula. Okay, so this is the proper way to approach isolating variables in formulas. It's worth it for you if you're considering eventually, possibly, university stream pathway for math and science. It's worth it for you to really try to understand the way that I found these formulas. Having said that, if you're finding that a huge struggle, I'm just going to show you a little trick here with this triangle. So I'm going to set up this triangle and put the D here, the M, and the V. Now, the way the triangle works, you don't have to do this rearranging of formulas here. If you want a formula for D, just cover up the D and see what's left over. M divided by V. See that? M over V. And that's this formula. If you want this formula, we need the mass. Mass equals D times V. So come over and cover up the mass. And do you see how what's left is the D and the V? So think of this line as multiplication. This line here is division. So if we cover up the mass, then it's just D times V. And that's this formula. If you want the formula for volume, cover up the volume here, and now you can see you're left with M over D. So the triangle becomes a memory tool. All right, again, if you plan on pursuing university programs in math and science, you should really be looking to understand the derivation. Okay, in terms of our format of laying out these problems, we're going to use the GRASS method. So I'll go through that as I list each step. I'll list each step as we go. So here I'm asking you in number 1 to determine the density. Okay, it always helps to kind of notice what's happening here. So they're asking us to find density. That's what I'm looking for. With a mass, okay, we've got a mass here of 15,000 kilograms and a volume of 5 meters cubed. All right, so, boy, that's a fine point there. Okay, so first step in the GRASS method is the G. You'll see the G here. And what we do with the G is list our given. All right, so I'll just write that here. Now, normally you can just put the G, but because it's the first example, I'm writing out the word so you know what it stands for. So the given is where you list the symbols with the values that you have for them. So right now I come over here and I see M equals 15,000 kilograms. And if I keep reading, I see there's a volume of 5 meters cubed. So you'll notice for the given that I'm listing the symbol, which you'll see back in your table, lining up the equal signs and listing the numbers with their units. That's the G. R is the required. So R is what we're actually trying to solve for, or what we're being asked to find. So you realize in this question, we're being asked to determine the density. So I come back here and say capital D equals question mark. So I'm using the symbol for density, right? And I'm putting a question mark because I don't know what it is, but that's what I'm trying to find. So that's the R step here. Now the A stands for analysis or analyze. And that's where we identify the formula that we're going to use. So I'm coming up here for the A, the analysis, okay? And here's where I'm going to choose my formula. Now which formula are we going to choose? Choose the one that has D isolated because that's what we're required to find. Okay, so for this analysis then, I'm going to choose the formula D equals M over V. And now we continue with the solution here. So the solution involves the substitution. So D equals, now I plug in that mass, 15,000 kilograms, and the volume in the denominator of 5 meters cubed. And then pull out your calculator. 15,000 divided by 5 turns out to be 3,000, and I write the unit kilograms per meter cubed. The last step of GRASS is the final S, and that's where we write a sentence or a statement, however you want to think about it. So the density of the object is 3,000 kilograms per meter cubed. Okay, so you can see the final statement here, or sentence. So let's continue to use the GRASS method and show our work for problem number 2. So as you read the question, right, underline when you see certain properties or quantities, find the mass, okay, so I'm going to be looking for this, that has a volume, okay, of 5 milliliters and a density of 3.17 grams per milliliter. Okay, so I come back over and start by listing the given. So I'm just going to put G so we don't have to write it out all the time. So given, I see a volume. So these are the symbols and values, measurements that you actually know. So we have volume and density. These two have been provided to us in the question. In other words, given to us. Then we list the required. Okay, I'm being asked to find mass, so I need to know the symbol for that is mass, is capital M, lowercase m. Then I think back to my formulas and choose the formula that has m on the left side by itself. That's what we mean by isolated, the variable is by itself. So now in terms of my analysis, I'm going to choose the formula m equals d times v. Then I go ahead and substitute the numbers, so 3.17 grams per milliliter times 5 milliliters. And hopefully you can see that the milliliters are setting up to be kind of a top and bottom thing, so my units are going to cancel nicely there. When you go ahead and multiply 3.17 times 5, you get 15.85 grams. Now that unit of G should make sense because that is the unit for mass. And you'll see it's actually the unit that's left over when the milliliters cancel. Now haven't specified what to round to here, so let's just say, just for practice rounding, let's round to the nearest gram. So I'm going to chop this off and look at the first neighbor. See this neighbor of 8 here? When that digit is 5, 6, 7, 8, or 9, then you bump this digit, the one you're rounding, you bump that up by 1. So we come up with 16 grams. So the mass of the liquid, right, now we can write our sentence. That was our solution that we've gone and done, and now we're on the statement. So these 3 dots mean therefore, so we say therefore the mass of the liquid is 16 grams. There we go. Okay. Now in the third example, we're going to determine the volume of a 50-gram piece of aluminum with density 2.17 grams per mil. Okie doke. So I'm going to see what I'm being asked to find, or read the question really, and just start noticing what I've been given and what I'm being asked to find. So it says determine the volume. Okay, so there's the question mark. That's what I'm going to be looking for. A 50-gram piece of aluminum. Grams. Go back to your table here. Right, go back to your table. What's measured in grams? Oh, that's mass, which we use a lowercase m for. So keep going, keep looking at these units and these symbols in this table until you get very comfortable. You need to know those symbols so you can recognize them. Right, here's grams, so we need to know that that's mass. Okay, with a density of 2.17 grams per milliliter. Okay. So we just started to read the question and realize what we've been given and what's required. So what have we been given? That the mass is 50 grams, that the density of aluminum is 2.17 grams per milliliter. What have we been asked to find or required to find? The volume. So you had 3 versions of the formula. You had density equals mass over volume, massity equals density times volume, and you had volume equals mass over density. So which one of these formulas is useful for us? Well, whichever one has the V by itself. So here's where V has been isolated, so that's the formula that we're going to choose. So V equals m over d, and we're all set up to plug in our 50 grams. This is our solution. Plug in our 50 grams and 2.17 grams per milliliter. And then we can go ahead and divide. You'll notice the gram units cancel, and we will be left with milliliters. Okay, so into my calculator, I get this number from my calculator, so I'm going to decide to round to the nearest milliliter here. So I'm going to chop it off there and look at the 0. The 0 is the neighbor that's going to tell me what to do with the 3. So since the 0 is a low number, 0, 1, 2, 3, 4, a low digit, I'm going to keep the 3 the same. Essentially, we say round down, but what you're doing is keeping that digit the same. So 23 milliliters. So the final statement here then, so therefore, the 3 dots, right? The volume of aluminum is 23 milliliters. So I didn't actually refer to the triangle when I was selecting my formulas. If you are using the triangle, then you would quickly sketch the triangle on the side of your page. And then when you need whatever you have the question mark for, that's what you cover up, right? You write that on the left side of the equal sign, cover that up, and then you can see that we have mass divided by density, and that's what comes up here. Okay, so that's how we approach these problems. Okay, and the idea is that when an object is less dense than another, it will float, just like the ice floats in the liquid water and the oil floats above the vinegar. Here's our heterogeneous mixture, right, with a less dense top layer. These terms matter, so be comfortable with those, please, as well as using their symbols and recognizing their units. We have 3 different formulas. Again, when I know the units of density, here I can figure out that for density, mass is in the top and volume's in the bottom, so that actually gives me the first formula. And using my math skills, I can derive these other 2 formulas just by isolating mass in this case and then volume. If this is way too much right now, then there's a triangle, right? And if you position the letters here and then just cover up the one that you're trying to find, you'll always be able to get the formulas. Use the GRASS method to show your work, and you're good to go.